Hi everyone, good morning.
Good morning, sir.
Great. Let's start for the day then. Before we start, again, if you have any questions with respect to what we studied yesterday in terms of any past exam question paper, I think I honestly think the only difficult part was, that question we did on is.ma, where we were trying to find out missing values and try to remove them out of the data set. I think that was the only trickier part. Rest everything was or should have been quite smooth. But anyway, nonetheless, if you have anything that you want me to repeat or you want me to reiterate, please let me know.
So basically,
Mm-hmm.
not directly any topic, but
Mm-hmm.
like somewhere we use the sum and the length function to find certain things. So like, how do we how does how should it come to our mind directly that we have to use this like in certain cases?
So you are saying irrespective whether I use a sum function or a length function, how do I get to know that?
Yeah, like both.
Okay. So see, so again, one instance where I remember we used the sum function was to find out empirical values, empirical probability. Um, so see, it's very sim. So how you should identify it is that if you want to count something, right? So technically, you should have two criterias for that. The very first is, do you want to count something, right? And second uh, is the counting based on conditions, right? So if you have these two pointers, right, you would rather technically then go for some or kind of length of something and a condition over here. I'll tell you why. So I'll just open up one question so that you understand a little better. Hmm. So here, if you see, the question says find out the empirical probability of so and so. Now, technically, we know probability is nothing but favorable upon total number of outcomes. So here, if you see, kind of, I wanted to count the number of instances which satisfy this condition. Correct. So one way is that either you apply a sum function on top of it. So if you see both of these may meet the criteria here. So firstly, given the problem statement, I actually want to count the number of instances which satisfy this condition. And by the very nature that I want to count, it's a conditional based counting, right? That whichever numbers are satisfying this criteria is the only number that I want to take into account of my counting. Hence, firstly, I have a condition, and since now I want to count on top of the condition, there's some function on top of that. Or alternatively, this could have also be done using the length function, in which you could have just written x square bracket, something like this. So technically, both of these are exactly the same. If you remember, yesterday only we learned that whenever I want to filter something or take a subset of something, you write the data itself and you put a square bracket to apply filter. And whatever is the criteria or the condition, you try to put that inside this bracket or the filter. Right? If you remember yesterday when we did the density question, we kind of filtered the vector wind, right? Using the temp category what we created inside these square brackets altogether. I don't think I have
Yes.
that code, but I hope you remember the yesterday's program.
Yes. Yes.
So, so technically, these two things are what you should try to remember in mind. That do you have a condition, and basis that condition, do you want to count something? So, if these two are technically met, you know probably start to work around something in this fashion. See if that makes sense.
Yes, sir. So can we go through the
Mhm.
last question that we did yesterday once?
Okay. Yeah, it was this question. Yeah, what exactly do you want me to solve? Let me know. I think the first A part would have been clear, right? This part would have been clear. This was, I think.
Yeah, so this was no, not this question, that question, chi-square goodness of factors.
Ah, okay. So that was the last question we did. Okay. Um. Yeah, here it is. Yeah. Yeah. Tell me, what is it that you want me to?
The
Yeah.
coding.
Program. Yeah. Sorry. Hmm.
So, like, firstly, I understood the observed frequencies.
Okay.
So, how do we go about the sample size? Like,
Okay. Sample size in the sense.
one
Hmm.
n values, I mean. Uh,
The parameter n.
yes, yes.
Okay. So let me, I think Anushka also had a similar question as to how do you decide the. So when you say n, it's the parameter n, right, of the binomial distribution.
Yes, sir.
Okay. I think Anushka also had a similar doubt yesterday or the same doubt yesterday. So see, think of it as let's forget this example. I'll give you guys a very simple example to understand first, okay? So let's say if my experiment is tossing a coin 10 times, okay? And the success is number of heads that I see in those 10 coins, okay? And it's an unbiased coin. So what distribution it will follow? Guys, what distribution
Binomial.
Binomial.
correct? You would expect to follow binomial. So I'm saying x, that is nothing but my number of successes, would follow binomial distribution with n comma p. Now, since it is an unbiased coin, what will be the value of p?
0.5.
Very good.
0.5.
50%. Absolutely right. Correct. 50%. What will be the value of n? How many times you are trying to throw the or toss the coin?
10 times.
Good. 10 times. So do you appreciate my n will be 10?
Yes.
So in this scenario, you are saying since x follows binomial, I switch to my screen, it's 10 comma 50%. So when I say x is nothing but the number of heads, so when I toss the coin 10 times, I can either see zero heads, I can either see one head or one success, I can either see two heads or two successes, or at max, you can see 10 heads or 10 successes because you only tossed the coin 10 times. So you cannot have 11 heads altogether. Either you can have zero heads or you can have 10 heads or something in between, but nothing beyond these 2 points. Do you appreciate that?
Yes, sir.
Now, what happens is, let's say if I give the coin to you and I ask you, Ria, perform the experiment. So as per the experiment, how many number of times would you toss the coin?
10 times.
Correct. So at stage one, let's say Ria had the coin and she tosses it 10 times and say you have five heads, for example. Okay. So this is nothing but experiment one. Similarly, let's say if I give the second time to Anushka, let's say if I give the second coin or the second experiment to Anushka, even she will have to toss the coin 10 times because that is what my entire experiment is about. I hope that makes sense,
Yes, sir.
right?
So
And let's say she get seven hits, for example. So this is nothing but my second experiment. So my sample information, what I have at hand is 5 and 7. This is what my empirical information is coming out of the experiment, right? Now, in this example, what you guys have, instead of tossing off the coin, you guys have number of MCQs a student is writing now. So just like each one of you here tossed the coin 10 times, here every student is writing an MCQ exam which have 10 MCQs in it. So just like, let's say, if I were to say, or if I were to plot a distribution as to, how many students got how many heads. Since Ria got 5 heads, Ria's frequency corresponding to 5, this is my X variable. Ria's corresponding frequency with respect to 5, here she will have an answer of 1. Since Anushka got 7, Anushka's frequency with respect to 7 would be 1, right? Let's say if everyone performs the experiment, whatever is the frequency, let's say even if Ali gets a number 5, then since Ria and Ali have two fives, the frequency becomes 2. So 5 will have a corresponding number of 2. That is what the exact thing is done over here. Whatever number of MCQ students score correctly, these are nothing but those number of students. That is the observed frequencies. This is nothing but your X. So here the experiment is with respect to how many trials every student is making. So here, since every student will be attempting 10 MCQs as a part of the test, every student is performing or is one experiment in the program now. Hence, my n stands 10. This does not stands for n or your parameter of the binomial distribution because this is nothing but your frequencies. What is the distribution you are trying to see? If you remember, chi-square goodness of fit test is nothing but trying to see how close or how far is the expected frequencies and the observed frequencies. If you see the formula, that's what it is. It is summation of OI minus EI the whole square divided by EI. Makes sense,
yes,
everyone?
sir.
So it's OI minus EI. Again, that formula, if you remember.
Yes, sir.
Yes.
Sir, so that means that if one student got 5 MCQs correct and some others got 5 MCQs correct, so that way the frequencies will be counted on.
Correct. So whatever number of students get 5 number of MCQs correct, that number will be written down over here in total. So if you and Ali have 5, the number will be 2 here instead of 15.
Okay.
Anushka, I hope yesterday when we had the discussion, you had the same understanding what I demonstrated today.
Yes, sir.
Okay, great. Ria, I hope this is now clear.
And also for checking the
Mhm.
like when we carried out the code, so we got to know that uh, the OI and EI will have some like the EI will be less than 5. So that warning message will come, right?
Correct. Whenever EI is less than 5, R will throw you a warning message. Correct.
So sir, if we don't get a warning message, then how will we
Then,
get to?
nay, if there is no warning message, then no, none of your EI is less than 5. You're good to go. That's why, if you remember, I taught you this thing, right? So you can save the entire function inside some variable name, and then you can just extract the expected value to yourself check if any EI is going less than 5 or not. If it is not going less than 5, I will technically not throw you a warning. It's as simple as that. But even after that, if you want to check, you can just use this functionality to understand if there's any EI less than 5 or not.
So that's why we did the revised test.
Yeah, that's why we did the revised test. Firstly, we understood where that leakage is, right? So we understood whether the leakage is on the right hand side, on the left hand side, where exactly the leakage is. Since we understood that the leakage is on the left hand side, we clubbed these two guys technically. If the leakage was on the right hand side, I would have, let's say, clubbed these two guys. So it depends where that assumption is being violated, and then you will try to patch that area up. So usually it's around the tails only. It's never in middle, mostly depending upon how the distribution is in the place. Usually it's either on the extreme left or it's either on the extreme right. So since it was on the extreme left here, I kind of clubbed everything on the left hand part over here. If it would have been the right hand part, you would have similarly worked on the right hand piece so that you are able to club and get the expected frequencies a lot more. So in the revised test, if you see the expected value, now it comes up to be 15. So none of the cells are less than 5. So that statistic what you make kind of is better off than previously.
Yes, sir.
Good to go. I hope that makes sense. That's give you a lot of clarity. That will give you a lot of clarity.
Yeah, yeah.
Okay, great. Anyone else? Whatever we did from yesterday's lecture, everyone, are we good to go? Can we start for today's piece? Yeah, Bhavani.
No, sir, I told good to go.
Okay, great, great. So let's start with the final piece of Unit 3, guys. So today we close Unit 3 in full. Because I think simultaneously we have also been doing a lot of past exam questions. Today we'll also do the same so that we have a fair confidence in terms of what is being asked in the exam, what is the difficulty level, and whether we are able to code it or not, right? So today we close unit 3. Next class, whenever we will be starting with linear regression and GLM theory with respect to. So we won't be doing anything in R. It will be just, understanding the basics of linear regression and GLM. Fair? Great. So guys, today what's the agenda? Agenda is simple. We will try to finish bootstrap as a topic. Try to take up a lot of more past exam questions before we wrap up the unit. Okay, simple and good to go. Great. All right. So guys, let's start with the term bootstrapping. Correct. So when you hear the term bootstrap, or if at all you have heard this term previously as well, what do you understand by the term bootstrap? Or you know, it's okay even if the answer is we haven't heard it before, so that's completely fine.
So like I have heard it in like finance something like
Fair. You might have heard it in the context of
business
correct,
startup.
correct. Startup. It's a bootstrap startup. No funding taken from anyone else. It was entirely the, let's say, founder's money. Fair, fair enough.
Yeah.
So this
And
bootstrap is more towards.
resampling for you see resampling technique used to estimate variability or
Hmm,
confidence interval in statistics. Correct?
correct, correct.
Like
Fair.
median by repeatedly sampling with the replacement from the original data.
Correct, correct.
That is
Absolutely.
in bootstrapping in statistics.
Correct.
Resampling it.
Hmm. Correct, correct. Fair enough. Um, so guys, if you see on my screen in the bracket, I've written bootstrapping as resampling. So, so again, I mean, Tom had the same thing, correct? So what do you mean by resampling? So we have heard the term sample, but what do you mean by resampling or resample?
We are repeatedly taking sample.
Hmm.
Suppose the variability to assess the correct variability, we
Hmm.
are repeatedly taking sampling with replacement. Then that is the thing resampling.
Correct, correct. Fair. Right. So guys, as he correctly mentioned, so when I say the term resampling, right? So sample we know that you have something with you in the bucket, and when you say take a sample, you kind of try to draw a simple random sample from this bucket. Let's say the sample is S1, right? Now, when I say resampling, it means that the re stands for repeated, which means that from the exact same bucket what I have at hand, which is over here, what I'm just marking it out in red color, whatever bucket of data points do I have here, I kind of repeatedly sample from this bucket. So I have one sample, similarly I can have another sample, similarly I can have n number of samples from this one, right? Now that n can be 1,000, 10,000, 20,000, whatever that number is. Basically, the term resampling is nothing but repeated sampling. Repeated sampling, I mean that instead of taking one sample, I will draw multiple samples from the bucket of observations what I have. Is this making sense, everyone? What do you mean by the term resampling in this context? Okay, thanks, Bhavani. Others?
Yes, sir.
Okay, great. Now, the first question is kind of clear here as to what is bootstrapping. So we learned or we understood that by bootstrapping, you mean it's a resampling method. By the term resampling mean you repeatedly draw a sample from a set of observations or from a bucket. Right now, what this bucket is what we will obviously discuss in a couple of minutes. But then you have a set, you have a population, or you have some form of data points here. And then from that, you keep on drawing samples, multiple samples, 1, 2, 3,000, 10,000, 1 lakh, 1 crore, whatever is that. Fair. So this is fine. But the bigger question, what we will try to answer is that why do I want to do something like this? Right? So why exactly do I want to resample or repeatedly generate samples and try to have that data in place? So one answer, obviously, I think two answers what Tom correctly mentioned. One is to assess the variability of the parameter. Fair. Second is also to kind of uh, get confidence interval. So when you say confidence interval, again, I hope you would appreciate technically the hypothesis testing piece also gets into the play, which is absolutely right. That's right enough. Anyone, any other view you would like to add here? Why exactly do you want bootstrapping?
To get more accurate statistic. The
To get more accurate
sample
statistics, where
Get the
to get a more accurate.
representative sample.
get a representative sample. Okay, fair. But then one sample should work, right? Why do I want to
Getting
draw
more
multiple?
accurate statistic.
Um, because in the one sample,
Yeah,
maybe from
yeah,
the
Anushka, sorry.
population, we take the one sample. It is maybe from the uh, some concentrated area. But
Hmm.
if we take the many samples, then it covered all the population, means all the areas of
Fair
population.
enough. Fair enough. So kind of trying to have more information so that it kind of represents the broader characteristics of the population. Fair, fair, good enough. Great. Yeah, yeah.
Another thing is that partitioning data for model
Sorry, which
value.
data?
We want to partition data
It's a partition data. Okay, okay, all right. Fair, fair
to get
enough.
a more accurate models values.
Mm-hmm. Okay, fair, fair, all right. Yeah, yeah, yeah. Go ahead.
So I was saying I didn't understand the requirement.
You did not understand the requirement.
Like you said two statements, right? One is to test the variability, assess the variability, and second
Mhm.
confidence. So I didn't understand how is it
Either of
related.
them. Fair, fair,
Yeah.
fair. All right, all right. No, no problem. We will discuss that. Don't worry. Um, okay, fair. I think great answers by every one of you guys. Chalo. So let's start with a simple statement to understand why is there a need for me to use Bootstrap, correct? Or why is there a need for me to kind of multiple repeatedly draw samples and then try to work around those samples, correct? So now tell me, if I ask you guys that I want to infer on the parameter mu. Correct. I want to infer on the population parameter mu. So let's say if I ask you guys, okay, tell me a 95% confidence interval. So even if you give me a range in which my mu would lie, I am happy with that. I don't want anything else. Correct. So what is the answer for this?
Sir, we don't know the distribution.
mu plus or minus 1, if it is 1.96 into sigma by root 10.
Fair enough. So Bhavani said, sir, we don't know the distribution. So at least in your theory, you guys have studied X bar plus minus, whatever is that Z quantity or the T quantity, depending upon, let's keep it T only. You have the T quantity and into you kind of have square root of sigma, or I can just write sigma by root 10. Everyone?
Mu plus 1.64.
नहीं 1.64 अच्छा 95% है. Okay, I don't remember this value. Huh? Okay.
1.96.
Yes, 95 for 1.64 in
1.96.
normal distance.
That is for general. That is a particular case. Correct.
Arey, but you guys are saying about normal. This is T.
Okay, sorry.
And how, and moreover, I never told you degrees of freedom. So you cannot find out even the value of T. So Z is fine, but Z you technically use when you tell that, okay, sigma is known. Technically, which is not. So this sigma you would estimate. So this sigma had technically in that way. Hence, it would start to follow T distribution. Right? So, I mean, again, that is not a problem statement. So, Bhavani, I hope that answers. So, you said, sir, we don't know the distribution. I don't know. So, at least as far as mu is concerned, this is what you guys have studied, right, in your books.
Yes.
Everyone, are we confident with this statement at least? So, there's nothing new about bootstrap here. It is purely what I've written down, what you guys have studied in your books in the previous semester.
Yes.
Yes, sir.
Yes, great. So now if you see here, when I have to talk about mu, I kind of used some form of assumption that things would come from normal when sigma gets unknown and I would have a distribution following this part. Correct? Now, if you see this very statement, there is an assumption. So if you remember, how do you guys calculate confidence interval, right? You kind of write down minus T, something like this, right? The quantity you write down over here, and then you equate it to 1 minus alpha. This is the starting point of confidence interval, if you remember. Now you
Yes.
use the very, very distribution of this T or the statistic of this T to, try to find out the entire confidence interval. Correct? Now, the problem is that what if this entire assumption is not holding true? So every theory what we studied in our lectures with respect to mu, with respect to sigma, with respect to lambda, with respect to p, kind of we had some or the other assumption at the back end for them to support my theory. If you remember our confidence interval as well, or if you remember our hypothesis test as well over here, if you remember, in every part we were saying exercise comes from normal, or this test statistic what I'm trying to solve follows T distribution, hence the term T test. Now I hope you would appreciate that in reality it's not always necessary that whatever theory I have studied basis the underlying assumption of normality or any other particular approximating distribution would hold true, right? Now the moment I say, let's say, if the distributions are not holding true, the entire theory will not hold true. If the entire theory doesn't hold true, you would technically not be able to find out confidence interval or do any hypothesis tests. Everyone?
Yes.
Yes. So this is where bootstrap comes into the game. So bootstrap tells you that even if your underlying assumptions with respect to your statistic does not hold true, that is, even if your assumption that you are saying that x bar would approximately follow normal with mu comma sigma, so the whole reason we wanted this distribution is because I wanted to infer on the population parameter mu. So when I take expectation of x bar, I know it is equal to mu, right? So that helps me work with respect to the population parameter mu. But if the assumption or the distribution in itself is not holding true from me, then I hope you would appreciate all the theory what you have studied, be it confidence interval, hypothesis testing, anything else. Kind of vibes of you are back to square zero because you don't have any estimate of the parameter or confidence interval or anything in terms of hypothesis to test. Is the problem statement clear, everyone?
Yes, sir.
Yes.
Now, what you are saying
Secondly,
is that without knowing the distribution, we cannot proceed further.
correct. Even if you know the distribution and if it is not holding true, right? Even if you know the distribution, you know the assumption behind it, the assumptions may not hold true at times. You are fairly right that at times, let's say if Tom devises a new distribution of his own and he may not be very well aware as to what distribution this particular quantity may follow, that is again one problem statement. That I may not know what the distribution may be. Second, even if you know the distribution, that x bar would follow normal. But what if that assumption in itself is not holding true? So both of these problem statements are what we are trying to cater here. Tom, is that making sense? Everyone, is that making sense?
Yes, sir.
Great.
Uh,
So, yeah.
it's still a bit
Hmm.
uh, not clear
Hmm.
for
Yeah.
me.
What is not clear? Let me bolo.
Like I understood that the maybe the underlying assumption can be false.
Hmm.
So like, what is the underlying assumption exactly? I didn't get.
That things are following normal distribution. Acha.
Oh, okay,
If you
okay.
if you were to talk again, that's why I started with this very statement, right? That if you want to, let's say, give me a confidence interval for me, in your books you have always studied t dot test function or you have studied the confidence interval for mu, assuming that things comes from normality. Hence, this is the statement what you write down in your books as well.
Yes,
Correct. So
yes,
this statement assumes, right, that kind of things were following normal. Since your sigma was unknown, you estimated sigma. Hence, your distribution boils down to t distribution.
yes,
Now, I boiled down to t because I assumed normality, correct?
yes, yes.
If that very base crux of my normality not being satisfied, would I be, would I be able to get here?
No,
No, right? Similarly, again, I hope you understand. This is mu mean of x bar and variance of x bar, which is sigma by n. यहाँ already लिखा है मैंने. Guys, I hope you understood. Don't take it on face value. This was
yes,
nothing but mean and sigma of x bar. Hence, I simply wrote x bar. The
yes,
sigma technically the standard error is nothing but sigma by root n. What we have already written over here. So don't get confused as to why I've written two different things in the same place. Guys, I hope you appreciate and understand that.
yeah.
Yes.
What
Sigma,
I was trying to write down.
yeah,
Correct. So now I'm starting to question this assumption itself. Or in this hypothesis testing theory, the very first test what we learned here. I said X comes from normality. This is what the assumption I wrote. Now, what if when you see a QQ plot or when you perform a chi-square goodness of fit test, the results come out that your exercise don't follow normal. In that case, is this test valid?
no, sir.
No, it's not valid. This test is no longer valid. So if this test is no longer valid, have you studied any other theory to draw hypothesis testing ka inference?
No.
No, you have not studied that, right? That is where now bootstrap comes into the place. Bootstrap says that it's okay even if your assumption of the underlying statistic are not holding true, irrespective of whether or not your assumption holds true or not. I can help you generate information with respect to the quantity you want to try to find out. Right? I'll repeat my statement again. Bootstrap says that even though this assumption basis which you have devised the entire theory, be it normality, be it T, if it doesn't hold true, that's fine. I understand that if the theory doesn't hold true, the assumption doesn't hold true, you can no longer use the entire theory what you have studied in your previous semester. Okay, not a problem. Bootstrap being there, Bootstrap will help you kind of get your confidence interval, help you perform hypothesis testing by ignoring or kind of devising a method that does not uses the assumption of normality on any other distribution now. Is that making sense, everyone? So now, if the normality assumption is not holding true, great. I don't care because Bootstrap does not require that. Or Bootstrap is there with me to help me answer the questions now. I don't care if sample is coming from normal or it is following normal or if my basic theories are holding true or not. That entire assumption backbone gets wiped off by Bootstrap. How is obviously we will see when we start to code, but is the base crux of bootstrapping clear, everyone?
Yes, sir.
Okay. Everyone, are we crystal clear? Ali, Bhavani, Kaustubh, Riya, Tom.
Yes.
Okay.
In
Ali,
Bootstrap,
are you
we are
there?
repeatedly taking samples,
Correct.
correct?
Correct.
Then that
Correct.
means
That's
if
what
the
you mean
sample
by
becomes very large, so it becomes 10 to normality, right?
10 to what? Gamma?
Normality.
No, 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 no. See again. See the whole, matlab, he has a very good statement, everyone. We should try to understand this. See, the whole perspective of Bootstrap is to get away with the distribution. When you say if I do something and if you say at the end I'm going back to normality, you are again defeating the purpose of Bootstrap. Bootstrap on its own, when it is being coming in the picture, it is trying to break the backbone of the distribution. It's trying to break and get away from any assumptions I have in the place. So in the bootstrap, my final goal is to just get confidence interval or hypothesis, let's say. My goal is not to get the distribution to normality. If normality would have been holding true in the very first place, I would have been happier with my theory, what I've devised in class. Since that is not happening now, I am on bootstrap. So you're getting away from the distributional assumptions in bootstrap. You're not going towards normality. You're not thinking about normality, gamma, any XYZ distribution now. I'm saying just let me get rid of the distribution now. I don't care what distribution it is. Bootstrap will take care of that. Now I'm not focusing on normality or anything else. Whatever it is, it will be. Guys, is that making sense? The whole perspective of bootstrap is to ensure that my confidence interval hypothesis tests are devised in a way that I'm getting rid of all the assumptions now. If my assumptions were in the place, I would technically use whatever theory I have studied, T dot test, all of those functions and all of those theories. Since that is not holding true, that is now a need of bootstrap comes into the game now. Now what to do? Bootstrap is the thing to do. Ali, Anushka, okay, thanks Bhavani, Kaustubh,
Yes,
Tom, I hope that's clear now.
Yes, sir.
Tom, good to go. Okay, great. So with that, guys, let's try to take on a quick example now so that you appreciate. So this is the entire crux of Bootstrap, right? Um, let's just quickly, take up a question to understand. So if I go back to this diagram, I told you guys that, I have this bucket with me from which I draw samples. Now, I never very specifically or clearly mentioned what this bucket is, right? Is this bucket a population or is this bucket something else? I never defined that, because this bucket, as to from what you draw the sample, depends on the type of bootstrapping. Correct? So you have two types of bootstrap. One is the non-parametric bootstrap. Now, what do you mean by the term non-parametric? Anyone? What do you mean by non-parametric? Or what do you mean by parametric? Can also answer in that way. Yeah, any attempts, anyone? It's okay even if you guys are wrong. There's nothing wrong in that. Okay. So guys, when I say non-parametric, it basically means no distributional assumption, right? So don't talk to me about normal distribution, gamma distribution, chi-square, Poisson, gamma. Basically, the entire program what we write down under non-parametric bootstrap will technically have no assumptions with respect to from which you draw this population, you draw the sample. So in non-parametric, this bucket of yours from which you will draw the sample is the sample itself, right? So if you are getting confused that are you trying to tell me that draw samples from samples, the answer is yes. You have a sample at hand and from this sample, you would draw multiple samples with replacement now. So all the samples S1, S2, S3 up to Sn will be taken out from the sample information what you have at hand. That is why the term non-parametric. I'm not trying to look after the population anymore now. Whatever is my sample information, I will use that to generate more information, more samples now. Is this making sense, everyone? What do you mean by the term non-parametric?
Yes, sir.
Others?
Yes, sir.
Okay, great. So let's try to take a question. We will solve that. And again, I will have a couple of questions. I have a couple of questions for you as well. Chalo, everyone pay attention for the next 5 minutes. The program is very simple because this is something what you guys have already done. So it's no longer the program that I'm worried about. It's only, the statistical understanding of it is what we should try and aim for. Okay. So suppose we have a sample of 10 observations from an exponential distribution with unknown parameter lambda. Correct? This is the sample observations what you have at hand. The question says write down the R code to obtain 1000 bootstrap estimates and display distribution. Also find 95% confidence interval of lambda. Fair? So here they are saying that you have sample observations X from exponential distribution lambda. Correct? Now, if someone is again getting confused that, sir, you told no distributional talks, again, there is some parameter that you are trying to find out in this example or in the context of bootstrap, right? So that parameter have to again be linked to a distribution. Initially, how what it was working that I had X follows normal, let's say with mu comma sigma. For me to comment on mu, I had X bar. And X bar also I was saying follows normal distribution with mu, and obviously it will have some standard error of its own, right? So one distribution was for X and one distribution was for the statistic, correct? Bootstrap is eliminating the second guy over here because obviously first guy is something where things are coming from. So I'm not interested as to, in this component in Bootstrap. Bootstrap is trying to take care of the second component, which is helping me infer on the parameter mu or whatever is that. Guys, is this understanding clear?
Yes.
That is law of that central limit theorem is we are not taking into consideration.
Yeah, because it may not hold true if you have very less number of iterations or sample data points. So whether it is center limit theorem, whether it is any other approximation, whatever it is, Bootstrap says I don't care. Just wipe it off. I don't care. I will devise my own method to give you estimates and confidence interval. If your assumptions or approximations are not holding true, just ignore them. Don't worry, I am there. Everyone making sense? Guys, any questions or concerns till here, let me know. Guys,
Clear, sir.
okay, great. So this is nothing but my sample observation. So I'll just quickly copy paste them here. So let's say these are my X observations, what I have in my sample. The question talks about I have to create a distribution with respect to lambda, and they have said mentioned 1,000 bootstrap estimates, which means that I have to draw 1,000 samples from the original sample. So tell me, how do I draw a sample from a sample? How do I draw a simple random sample with replacement? Which function do I use?
Sample.
Very good. Use the sample function. X. The size of the sample will be equal to the size of your original sample information. So even if you don't write anything, that's completely fine. Since it is with replacement, I will write replacement equal to true. Let's say this sample is S. Now, once I have the sample, what do I have to do? Guys, once I have the sample, what is it that I have to do of the sample? What is the parameter I want to estimate?
Mu.
No, it's lambda.
Lambda, yes.
Correct. So is there a relationship between lambda and X size?
Mean.
Yes,
One
very
by
good.
one by one by mean. No?
Yes, absolutely right. So if my distribution is lambda, I know that expectation of X is 1 by lambda. If I just take lambda on another side and get my expectation of X on another side, this is the equation. We know that expectation of X is nothing but 1 upon mean. So can I say if I want to estimate a value of lambda, it would be nothing but 1 by mean of S. See if this is making sense, everyone.
Yes, sir.
Yes.
Since I have to do it 1,000 number of times, what should I do?
For loop.
Very good.
For
Use for loop for I in 1 to 1,000. This is my operation. Get this inside the body. Correct?
Sir, lambda vector. This is
Yes, very good. You again initialize the lambda vector and put an indexing here because lambda will no longer take one value. It will take 1,000 different values. See if this is making sense, everyone.
Yes.
Yeah, see, that's it. This is what bootstrapping is all about now. Now we have kind of been seeing this program right from, day one or unit one. Is just that now we also learned it in the context of bootstrapping. So the programming bit is kind of what we have already known. Nothing to worry about that part. See if that's making sense. Right?
yes.
Chalo, great. So let's run the program. The question says highlight the distribution of lambda. How should I view the distribution of lambda now? Using which function?
Histogram.
Very good. Since lambda will be a continuous value, a histogram would help me here. So I would run the function hist and see you have everything in place here. So this is nothing but your distribution of the parameter now. Lambda ka distribution hai. Everyone, is that making sense? And for you to generate this distribution, you did not take any assumptions on the approximation of lambda or where from which the sample was generated. See, everything is distributionless here. Hence the term non-parametric bootstrapping. Is this making sense, everyone? If any point is not clear, let me know. I will discuss it again. Everyone, are we very comfortable with the concept of bootstrap, where it is coming and how are we performing it?
Sir,
Sorry, Bhavani, you said you yes or no?
no, sir, I had a doubt.
Yeah, go ahead.
Like after performing the sampling, like we found we have lot of samples now.
Correct.
Then after plotting the histogram, we have a question display the distribution. So should
Mhm.
we write something for that? Because
Write
they
something for.
have given exponential distribution here,
Mm-hmm. Correct.
but the answer what we got is not like that. So I had a doubt.
Take that in the sense.
The histogram is like a positively skewed distribution. So
No, see again. Your again, guys, that is why if you remember, I wrote 2 pointers here initially. See, Bhavani, x follows exponential with parameter lambda. Correct? That is given to me in the question.
yes, sir.
Will lambda also follow exponential? Did we learn anywhere something like this? Or do you think this should also be the case then?
Oh, got it, sir. Yes.
Getting it?
Yes, yes,
This
yes.
was that's why if you remember just a couple of minutes back, I wrote 2 pointers. Right? If you remember, I wrote something 1, 2, and then I was trying to say bootstrap is catering to the second piece. This is what bootstrap is trying to cater to. The one I'm highlighting on line 16. I am trying to talk about lambda now, right? Because obviously this you will have to know what the distribution is for me to understand and appreciate what distribution is. See, that's where we learned QQ plot before. That is where we learned chi-square goodness of fit test yesterday and day before yesterday. So that I can understand what my population is, what the distribution of my population is. Once I get to know the distribution, that okay, my population comes from Poisson, gamma, normal, log normal, Pareto, Weibull, Burr, whatever it is. Once I get to know the distribution, now the second problem is to understand what parameter I want to talk about. What will be the estimates? What will be the confidence interval, hypothesis testing, all of those bits and pieces. Now, since the distributional assumptions or the approximating assumptions of this parameter is not being followed, this is where Bootstrap now comes into the place. So Bootstrap is solving the problem for parameters, unknown population parameters, not the distribution. If you don't know the distribution at hand, you're technically you cannot work with population parameters. I hope you appreciate that. Unless it's a very generic key, tell me population mean, tell me population variance. That is something very generic. You can talk about that even without a distribution because mean and variance is very generic term, right? That's what we have learned under measure of central tendency and dispersion, right? But if I tell lambda, now the question is, what lambda are you talking about? Are you talking about gamma, alpha, comma, lambda ka lambda? Are you talking about Poisson distribution ka lambda? What lambda you're exactly trying to talk about? That will also come into the play, right? So this is what I'm trying to talk about. So we have never learned any theory that if x follows exponential, lambda would also follow exponential. We never learned that. I hope that makes sense.
Yes, sir. Got it.
Yeah. You had something, I think, when you raised your hand.
So me?
Yeah, I think someone raised their hand, right? I'm not sure.
No, sir.
Okay, yeah, Anushka. Sir. Yeah. Go ahead, Anushka.
Sir, can you please go?
Sorry, can I?
Code. I want to see the
So you want
code.
to see the code? Okay, yeah, this is the code. Hmm. Let me know if you have any questions here.
Sir,
Mhm.
the values of XR means that is are given in the questions.
Correct. That is given to me in the question. This is nothing but the
But,
sample what you collected from the population. That it's that information. Yeah,
but
go ahead.
how we use that in the means that sample node, I am not able to understand.
Okay, so let's say you have this set of observations. You are just trying to draw a simple random sample out of these observations. So for example, if I have X and if I just write sample X, replace equals true. So I just went or R just went to this bag, took a simple random sample with replacement and given it back to you. So if you see 2.77 is being repeated twice, 5.44 is being repeated twice because it's a sample with replacement and hence observation tends to repeat. You again draw a sample, you again draw a sample, you keep on drawing samples with replacement. So that is what is happening at the back end, thousand number of times.
Okay, okay. Now I understood.
Yeah, getting it. So you are just repeatedly drawing samples so that you kind of capture or generate more pseudo samples, right? So you call them pseudo because they are not. I hope you understand. Right? By the term pseudo, it means false.
Yes.
Technically, they are in a way false samples only.
Yes.
Everyone, are we very clear with this? Is everything with respect to Bootstrap very clear? What it is, why do we do it, and how are we doing it in program?
Yes.
Okay, others, Ali, Kaustubh, Tom. Okay, great. So now that is not the end of the question. The question also says find 95% confidence interval of lambda. How will I find 95% confidence interval now? That is what you guys will tell me. I will not tell. If I have a distribution in front of me, how can I calculate a 95% confidence interval?
Means, sir, we have to look at the distribution of lambda here.
That you will have to now assess, given whatever we have discussed. You have to tell me. Doesn't matter even if you're wrong. That's okay.
Um, as per
Whatever
the
you have understood, try
Instagram,
to make a judgment on that. Whatever you have understood, try to make a judgment on. Yeah, yeah, Anushka.
as per, as per the distribution of lambda is positively skewed, so we have to use chi-square or t
Again, guys, fair enough. See, the whole perspective of Bootstrap was to get away from the distribution. When you say chi-square, you're again going to the distribution. I don't want to go to the distribution. If things were falling in place, I would have already used those theory back already. So now if you see the program, do you see anywhere me using any distributional information to calculate or to work around lambda? No, there's no chi-square, there is no normal, there is no t. So even if it is positively skewed, I don't care if it is following gamma distribution. In the sense, Bootstrap doesn't care if it is following gamma, exponential, or chi-square. Bootstrap
here we have to give the
for me to kind of pull from the theory of distributions. Now I don't want to go back to the theory of distribution. Yeah, go ahead.
here we have to give the 95% confidence interval for lambda value, no?
Correct. So I have to tell that 95% of the times lambda would lie between this and this. How would I calculate that? So what you're saying, Anushka, is right. That's what you have to try to tell. 95% confidence interval for lambda. So lambda ka distribution is on your screen.
Pointer.
Yes, very good. Now, guys, if you understand lambda, what you have devised over here is nothing but an empirical distribution. When I say empirical means you calculated it using sole sample information rather than theoretical information, right? Now, when I say 90%, 95% confidence interval, it's nothing but, can I say, if you remember this probability statement, what I wrote. Again, I don't know, I have the habit of deleting everything. If you wrote you guys write something like this, right, in your books, if you remember, alpha by 2 less than z alpha by 2 equals to 1 minus alpha, if you remember,
Yes, sir.
right? You remember this quantity,
Mm.
if I were to draw it out on my paint, it looks something like this, correct? So you have a normal distribution, and this quantity is saying that my z value, my random quantity, lies between these 2 points. Minus z alpha by 2 is here, plus z alpha by 2 is here, because normal is a symmetric distribution. So alpha by 2 error gets cut off here, right? And I'm saying this area under the curve is nothing but 1 minus alpha. So technically this was nothing but your, I'll just highlight it in red. This was nothing but the quantile points you used to gather, right? And since you never had the distribution of mu, you had the distribution of z. That is where you guys used to substitute x bar, minus mu, and all of those different theories or whatever it was, or x minus mu in general, something like that. Is that making sense, everyone?
Yes, sir.
So absolutely right. You would use a quantile function because it's an empirical distribution. What do I want to find quantiles with respect to lambda? So what will be the probabilities if it's a 5% confidence interval, guys? It will be 2.5% and 97.5%. That is where I'm dividing both the errors equally on either of the tails. Yes, no.
Yes, sir.
So this confidence interval, what you get is nothing but the confidence interval for lambda. So I say 95% of the times my lambda value would be between 0.24 and 0.70 approximately. You can also plot these quantile values on the histogram using AB line, right? So since confidence interval would be vertical lines, right? You have a key letter called V equals to whatever values you want to plot, you can give that. Let's say we give it a blue color, and let's say we give it a thickness of 3 pointers. Yeah, so if you see my chart here now, see this is the confidence interval what you have. Everything that is between your blue bars over here. Is this making sense? Is this good to go,
Yes, sir.
everyone? So what Tom was trying to tell about variability and all stuff, if I want lambda hat is nothing but mean of the lambda distribution now. If you want to see how much variability lies in lambda, then you simply take variance of lambda. So I say on an average, lambda takes a value of 0.386 and it has, let's say, a standard deviation of or standard error of 0.12, right? So it also helps you understand how volatile or how variable your estimate is. I hope everyone appreciates lower the standard error means more precision in my estimate. I hope everyone you understand that.
Yes, sir.
Makes sense? Is that good to go, everyone? So you can also calculate variability of the parameter, mean, estimate, all of these things just via the distribution now, via the empirical distribution at hand. Is this entire thing clear? Good to go, everyone?
Yes, sir.
Yes, sir.
Great. Do you guys want to type this down or we can move forward to the next problem statement?
Sir, we'll type it.
You want to write it down?
Yes, sir.
Okay, fair. I'll just zoom out my screen so that everything gets on the same page. I'll just
So,
throw it here.
sir, can we get the question in the chat?
Yeah, I'll throw the question in the chat box. Done. So everyone get started. Let me know once you guys are done. We will move forward. Guys, let me know once you guys are done. Guys, done? Everyone?
Yes, sir.
Okay, great. Everyone, others?
Done, sir.
Ali, Tom, Kaustubh.
Yes, sir.
Okay, great. Thank you. Now, with this, we move on to the last part of bootstrapping called as parametric bootstrapping. Right? Now, again, if anyone tells me that, okay, let me throw it to you guys first and then kind of shout out you guys. And when I say parametric bootstrap, now what do you mean by parametric now? Think carefully and answer. So in non-parametric bootstrap, there was something which I explained, right? And you guys agree that we understood. So I take that as an assumption now. So now when I tell that, okay, next piece is parametric bootstrap. Tell me what is your understanding in terms of parametric now. So obviously non-parametric was no distribution. Parametric means there will be some distribution.
Yeah,
But
there will be some distributions.
sorry,
Means
There will be some distribution assumptions.
correct. But distribution of what?
The parameter.
distribution of parameter.
Again, go
Data.
back. What did we discuss? Bootstrap
But sir,
is getting away from the distribution with respect to the parameter, right?
No, like in non-parametric, we like from the sample we took is like a
Hmm.
general thing. We got a x, we used the sample function and we did that. But in parametric, we will not use sample, but instead we can use any function like an R norm or something, a random
Correct.
thing like.
Yes. Yes. Absolutely on point. Guys, again, see, the whole perspective of Bootstrap is to get away from distributions when I'm talking about the parameter at hand. That is why, again, I'm telling you guys repeatedly that there are two statements what you're trying to understand here. One is the distribution of X. Another thing is the distribution of the parameter I'm trying to work upon. The entire second story is independent of any distribution. I am not making any assumption that lambda would come from normal, gamma, exponential, or whatever XYZ that distribution is. Bootstrap is ensuring that the entire two comes empirically. By the very definition of empirical, I'm not concerned whether it comes from or it will start to follow normal or whatever XYZ distribution it is. That is why if you remember this chart, I told you you will draw some bucket. You have some bucket and you would try to draw samples from this bucket, right? Now in non-parametric, you had the sample and you were taking samples from sample. In parametric now, you would kind of assume the population to be normal distribution or whatever it is, right? So in the entire question, everything remains the same. Each and every data point remains the same. It's only the way you draw the sample. Line number 6 changes. So since I am assuming or I'm confident that things comes from exponential, I will draw a sample from the exponential family with, let's say, number of data points my x has, hence length is equals to x, and my lambda would be nothing but 1 by mean of x. See if that is something what you would appreciate now. So the entire program remains the same, exactly the same. Only line number 6 changes between parametric and non-parametric bootstrap. When I say parametric, you assume things with respect to x. When I say non-parametric, you are saying I don't care what the distribution is. Whatever x size information I have, I will try to use only those informations into the game. See if you have any questions here, or if it's getting confusing, let me know. We will discuss in a little more detail.
Sir, it's getting confusing.
Okay, fair. Others? What about others?
Sir, the way we have parametric and non-parametric in the bootstrap form, it is also in the theoretical form also. Parametric and non-parametric distribution.
What do you mean by non-parametric distribution?
Means, maybe sampling methods parametric, non-parametric. Is it like that?
Yeah, broadly, yes. Simple random sampling is not assuming any of your x size distribution. Yes.
When you ask the question, you ask you ask that I explain non-parametric, now you explain parametric. So you don't explain the bootstrap parametric. So that's why I will do that answer.
Okay, no, see, that is fine. That is not a problem. That's fine. That is fine. Don't take it that seriously. But do you understand why the statement changes, or how is it? I'll again repeat. I'll just summarize everything for you, everyone. See, I have a population at hand, and that population comes with some parameter, right? Assuming I'm trying to model waiting times. Now, by the very definition of waiting times, we know, and let's say it is established that, okay, waiting times follows exponential distribution. Now, my problem is, okay, exponential agreed. But with what parameter? Now, this lambda is what that I want to estimate. I want to get a confidence interval about. I want to perform hypothesis testing so that I could understand about lambda a lot better, right? Now, for me to comment on lambda, my initial theories, what you devised, were using normality assumptions to for me to talk about lambda. Now, what if those normality assumptions are not holding true? Then I cannot talk about lambda because the theory doesn't hold true. That is where bootstrap is coming in the second part. Again, I'm repeating, bootstrap is not coming in the first part. Bootstrap is coming in the second part to help you comment on lambda. I am now trying to get a distribution, an empirical distribution using bootstrap, right? So when I say parametric bootstrap, you are using the population distribution to generate samples. When I say non-parametric bootstrap, you are not using exactly the exponential information. You are only using your x size to generate more samples. That is the whole and sole difference between parametric and non-parametric. Again, if you see the lambda, what you are generating is purely basis empirical information. Whatever samples you generate. In one way, samples are generated from samples. That's non-parametric. In the second part, samples are being generated from the population distribution itself. So you're directly going to the population, collecting a sample, coming back. Going to the population, collecting a sample and coming back. In either of them, you never spoke what the distribution of lambda would be. You just gave it a formula. Now, whatever formula this will lead to is what the distribution will be: symmetric, positively skewed, negatively skewed. I don't care on that respect. Whatever it is, it will be. I am only interested in whatever the empirical distribution is. However it is, doesn't matter to me technically. Again, that is why Bootstrap is trying to help you the problem of lambda, not of x. See, there are two different statements here. I am not trying to talk about population. Population is x. I am trying to talk about the parameter lambda over here. This is what bootstrapping is helping me solve. When you draw samples, you're drawing it from x. I hope these two statements are clear, everyone. Ria, Anushka,
Yes, sir.
Ria.
Yes, sir.
No, see, if it's not clear, it's okay. It's okay to say it's not clear. That's completely fine with me. We can spend more time to understand it.
So basically, in parametric, we are not looking at the distribution of the parameter.
That is the same in non-parametric. That is the same in both of them.
Okay.
See, again, that is why if you see my very first starting point of Bootstrap was that I want to get rid of distributions now. When I said I want to get rid of distributions, I mean I want to get rid of the distributions that my lambda was expected to follow, what my x bar was expected to follow, not about the distribution my x would follow. Do you appreciate that? Acha, let me tell you, let me make it more simple for you guys. If I say x follows exponential distribution, as per whatever you guys have studied in your last semester, if x follows exponential, what is the distribution of x bar?
It's also exponential
Okay.
because it is from the lambda distribution we know. So x bar also can be a S bar. I think it is gamma or something. No,
It is Poisson distribution.
Poisson.
No, it is the summation of x bar, so it follows
is
the
gamma. xi is a lambda exponential. Then x bar sigma of x bar is a lambda. So sigma bar x bar is a gamma. I think. Is it so?
Okay. Fair.
Sigma xi is gamma.
Okay. Let me redirect you guys. What
So
is the
sigma
concept of
xi
PLP? What is
xi
the
is
concept of
lambda. Sigma xi is gamma. So
Mhm.
then it can be gamma.
Okay. Fair. Guys, what is the concept of CLT? Can anyone just quickly help me
You
revise?
mean central limit theorem? Huh?
Correct. Central limit theorem.
Central theorem, yeah. Central limit theorem says that if it is some arithmetic mean of this thing, xi's are follows that uniform this normal distribution, right?
Okay. Guys, if you remember the concept of CLT, it says that if x follows exponential, basically CLT says that I don't care what the distribution of x is. Exponential, normal, gamma, doesn't matter. If you try to find out the distribution of x bar with large number of iterations, I hope you remember this would now start to follow normal with its respective parameter. Do you remember that?
Yes, sir.
Yes, sir.
Correct. So is the distribution of x and x bar the same? No,
Sir,
it's not the same.
No.
Right? So this is what I'm trying to challenge here, that for me to, let's say, talk about lambda, I was trying to work with, let's say, x bar, for example. Correct? Now, under my theory, I was expecting that x bar would follow normal with some parameters, which would help me, let's say, devise some confidence interval or some hypothesis test. Now, since this second part, now if you use, now this is what you have to compare these two guys, right? I'll again make this x bar, let's say, for simplicity.
sir, if the samples are small, this x bar lambda exponential lambda follows this gamma. Now, if the samples are high, then CLT you apply, correct?
Yeah, exactly. So whatever theory you have devised, is it basis gamma distribution? Now I'm not debating whether it will go to gamma or not. That is not my concern at the moment. I'm saying whatever distribution it is, did you devise all your theory, all your mathematics basis that distribution, or did you devise everything basis normality?
The normality.
Basis normality, right? So
Yeah.
if this thing is not following true, what would you do? What
We
theory?
do the bootstrap.
Exactly, that is where bootstrap comes into the place, correct? So bootstrap says I don't care what this distribution is. If it is following normal or not, that's completely okay. I will help you devise an empirical distribution. You don't need normality, or you don't need support of normality anymore now. So if you see both of these quantities, let's say, are exactly the same. It's just that one, you assume things to follow something. Second is saying doesn't matter. I will use my own information to devise the entire distribution. See if that is making sense, everyone.
Yes, sir.
This is what we are trying to solve part 2. I'm not talking about X anymore in the distribution or in Bootstrap. When I say I'm drawing a sample from exponential lambda, I'm talking about X size. Bootstrap is not to talk on X size. Bootstrap is to talk on parameters and statistic. X bar, variance, lambda, beta, gamma, alpha. It's all the parameters. It's not the X what I'm trying to talk about. Guys, see, it's okay if you say we don't understand it. That's completely fine. So well, don't give me false, what do you call it? False justification that okay, we understood. It's okay to be honest and say we did not understand it. That's completely fine.
Means, sir, what we are learning in the theory, that is the based on X, that based on the X data. Means what is our random variable data? Okay, X follows something normal or exponential.
Hmm.
In Bootstrap, we are doing for the lambda parametric. For the
Your
parameters.
theory was also, see, your theory was also on estimates only. Your theory was also trying to talk about parameters only, but then they used to come with certain set of assumptions that if normality is there, see, you see here, na, you say X follows exponential, then you're saying as per CLT, X bar would follow normality. You made this statement.
Yes.
Now, what my question is, what if this approximation is not holding true? If the approximation is not holding true, then normal distribution is an incorrect approximation to take. Then how would I devise my confidence interval? How would I
Means
get my
all
hypothesis test? Mhm.
means all these are assumptions are predefined. Means
Correct. Absolutely. Absolutely, right? Everything was predefined in your theory. If that predefinition is not holding true, then all of that is something which you cannot use. Correct. Guys, what's the status?
Got it. No.
Got it? Great. Bhavani is good to go. Anushka.
we understood, sir.
Mm-hmm.
Means what you said, I understood, and main idea behind the bootstrap, that also I understood.
Mm-hmm.
But in bootstrap also we using the X values.
Correct.
We are generating the same samples from that X values. In our norm, okay. In our theory also we are using the X values to find the parameters, means
Mhm.
mean variance.
Correct.
But
Oh,
the so only difference is that there are some assumptions in the theory that are predefined, and we just follow that assumptions, and we end to our conclusion. That is our confidence interval.
fair, fair.
But
So see, in theory, there are two assumptions you're trying to make. One is on X and one is on the statistic. Agreed?
yes,
In Bootstrap, I'm saying I will get rid of two. I will get rid of the distributional assumptions on X bar or on the statistic. See if that simplifies a lot of things. Bootstrap says instead of making two assumptions, I will only keep one assumption that is on your X. And that too, if you're using parametric bootstrap. Non-parametric doesn't even take that into account. Non-parametric just takes simple random sample. See if that is kind of helping you get everything
Okay,
in
means it
right.
is not based on the, we are not talking in our bootstrap, we are not talking about the distribution of our parameters. We are only consider only means while we are processing that bootstrap, we are only taking the values of X. And by using that values, we are trying to find the distribution of our, sorry, no, not distribution. We are find the
No, you are absolutely right. We're trying to find distribution, but it's an
of
empirical
lambda.
distribution. Correct. You're
Means
absolutely right.
empirical distribution of parent. Okay.
Correct, correct. See, you are finding distribution only. It's just that it is not a predefined statistical distribution now. आप ये नहीं बोल रहे नॉर्मल फॉलो करेगा chi square फॉलो करेगा. It is some empirical distribution. Now it may not be normal, it may not be chi square. Whatever it is empirical driven.
Yes. Now I understand.
Great. Ria, Tom, Kaustubh, Ali. What about you guys? Are we good to go? Okay, Tom have given a thumbs up.
So
Great.
there are two approaches to bootstrapping: parametric approach and non-parametric approach. In parametric approach, we assume the distribution of the data, and then from there we are finding the parameter. From there we are generating a new data set. Correct?
Correct.
In parametric. In
Correct.
non-parametric, we are not assuming any kind of a data distribution, right?
Correct. Correct. Good.
Okay. This is okay.
Good. In fact, with that, nahi thanks. Matlab, that just helps summarize. I'll just quickly plot it on an Excel. Thanks for that, Tom. So when I say non-parametric bootstrap and parametric bootstrap, right? So in non-parametric, do I assume anything with respect to X, what X follows? Or do I, matlab, when I generate my sample, do I generate it from this exact sample or the distribution?
Yes.
Non-parametric, we are not assuming anything.
Exactly. In non-parametric, you don't assume anything of the. So do you generate sample from X or generate sample from exact distribution? In non-parametric, do you get your sample? I hope when I say sample, I'm saying X size. Yes, no.
Non-parametric.
We are generate the samples from the exercise only. We are taking.
I mean, so X size from statistical distribution, let's say. So do you always, let me further simplify it, sample from distribution. So whether you, so what do I mean by sample from distribution is, do you always go to a population and collect a sample? That is what I'm trying to tell you.
No, for non-parametric, no.
No, good. In non-parametric, the answer is no. What about parametric?
Yes.
Yes. The statistic. Now, when I say statistic, it can be X bar, lambda, beta, alpha, gamma, mu, sigma, anything what you want. Right? Is there any statistical distribution? Empirical distribution, yes. Is there any statistical distribution I'm trying to generate in non-parametric?
No.
No. What about parametric?
No.
Yes, very good. So this is what I was trying to tell. That the entire distribution of your statistic is completely empirical and non-distributional based. Whether or not you take a sample from the distribution or not is what goes into yes or no. Bootstrap is helping me solve this problem. See, now this helps you guys summarize everything into one snapshot. So what Tom kind of highlighted or summarized, it was kind of this in this grid what he was trying to tell. Guys, is this crystal clear now? Since these two are no, this is what I'm talking about, bootstrap. See, it's completely empirical. Bootstrap is not talking about the first one. It's not talking about the third component. It's talking about the fourth component, the fourth row on my Excel sheet. Guys,
Yes, sir.
Bhavani, Anushka, Ria.
Yes, sir. Got it.
Understood, sir.
Okay, great. Tom, I hope we are good to go with this. Okay, great. Great then. Um, again, uh, fair, I understand. You guys can just go back home, try to maybe, watch this lecture again, try to, just again understand things once again once you go back home. It's okay. Even if there's something further you are not convinced with, you want me to discuss that again, I'm very okay to discuss it again. Not a problem. It is a little confusing concept, so that's completely fine. Go home, take some time, revise it, see the lecture again. Maybe if you hear the same thing twice, maybe you guys will have a better understanding of that. Not a problem. We can just take some days to settle it. If at all there's something not yet clear, right? You guys can just let me know. I will come with some better visual examples for you guys to appreciate and understand. Fair, simple, good to go, everyone.
Yes, sir.
Great. Let's take a quick 10 minutes break and then we will come back and solve questions on bootstrapping.
Yes,
Fair.
sir.
Chalo,
Yes.
great. So let's connect back at 49 and we will start with some exam questions on bootstrap. Chalo, bye bye.
Okay, sir.
Guys, are we back? Okay, thanks.
Yes.
Great. So again, just to refresh, it's okay. Go back home, take your time, see this recording again. I think we'll probably meet next Saturday only. Um, Completely fine. Take your time. If at all you still think that we are not confident, we are not comfortable, that's absolutely all right. Just drop me a message by Thursday or Friday. I will prepare something for you to understand better. Everyone, good to go with that?
Yes, sir.
Okay, great. Chalo. Um, with that, let's move on to solving some exam questions on Bootstrap. So Bootstrap, you can say, is kind of, examiners' favorite thing in IFOA as well as in, in IQS. So probably if you, kind of try to see past exam papers, you will broadly see at least one question on Bootstrap, and often it comes for about 12 odd marks. So yeah, let's get started. I'll give you guys a simpler question to start with, and then obviously we will move on to more difficult questions on Bootstrap. Great. So let's start with this question. This is IFOS 2019 attempt. I'll see if the snapshot thing works today. I think there is some update to the software because I think it works someday, it doesn't work someday. Strange. Great. I pasted the image in the chat box, everyone. I paste image of another question. So someone is done with that. In case you can start with another question as well. I'll also paste the X vector for this question so that you don't have to type it on your own. We will save a couple of minutes. Done. Great. Everything shared on the chat box. The very first question is what we will do, what you see on my screen, right? I will give you guys 5 odd minutes. So it's approximately 53 now. I have time, or you guys have time until 58. Sounds good, everyone?
Yes, sir.
Great. Get things started. At 58, 59, we'll start to discuss. Chalo. All right, time's up, everyone. Uh, let's start solving the first question. I'll quickly type down. You guys can see, right? If you have the same solution with you, and if there's any discrepancy or doubt, you can let me know. Correct. So our studio. Let's get with the first question. Great. So the very first question says estimate the expected value of x. How do I find out the expected value of x?
Mean of x.
Mean
Yes.
x. No?
Mean
Yes,
x.
absolutely right. Yes, good. Expected value is nothing but the average value. That is nothing but simply mean of x. So the a sub part, that's it. Nothing else required. This is just mean of x. You have an answer of 0.57388. You're good to go. Nothing to worry on that. Next, it says calculate a 95% confidence interval for expected value of x, which means x bar or mu that we're talking about, assuming that x is normally distributed. Fair. So what should be the program here? Yeah. So guys, assuming that my x follows normal distribution, how do I calculate the 95% confidence interval? Have we studied any function to do that?
CI.
Very good. It's nothing but t dot test. So I have t dot test. I write down x. Since it is a 95% confidence interval, everything is by default. I can just, I think, write down conf. I don't know if that will work. Let's check. Yeah, it does work. So you have your confidence interval from 1.13 approximately to 5.42. See if that is the exact same answer we are getting. Oh, hold on. This is a small x, this is a small x, this is a capital X. I'll have to switch to a smaller x. Yeah. So about 0.4276 to 0.72. See if that works. Everyone of you guys, did you get the same answer? Yes, no.
Yes, sir, got the same answer.
Yes, sir.
Great. Great. Moving on to the C part now. Construct a confidence interval for expected value of x using the bootstrap method with 10,000 bootstrap replications. Is it a parametric bootstrap or is it a non-parametric bootstrap?
Is a parametric bootstrap.
Okay, others.
Non-parametric.
It's a
It is a non-parametric.
A non-parametric bootstrap because the question never asked you to generate x size or expected value of x using some distribution. Correct? So using this information, it is a non-parametric bootstrap. So since I'm talking about mean here, I will have to generate a blank vector for loop because I want to make 10,000 replications, right? Since the sample would come from X itself, I would have to do it with replacement equals true. I would save the respective mean values of S inside the loop and I am good to go. And I'm also expected to find the confidence interval. So we have already learned use the quantile function of mu. Probability stands for 0.025 and 0.975. See if that makes sense. I'll just quickly execute the program as well so that you guys can compare the answer. Mu not found. Sorry, I have written down mean here and I'm using mu below. So it will be mean and mean. Great. So 1, 2, 3. Good to go. I'll also quickly run down on the t-test confidence interval. Yeah. So guys, see if you have this answer 0.46 to 0.7188, something like that. So our answers will not exactly tally because we never set a seed. So see if it is approximately in that range. Or if this is the program what even you guys executed.
So can
It will
you
be different for different people, no? Or it will be same for all people.
It will be different. So let's set a seed. Let's set a seed of 1. And let's just execute the same thing again. Now our answer should be exactly equal. Yeah, Ria, you were trying to tell something.
so can we see the code once?
Yeah, I have it on my screen.
Yes, I also did the same, but
Chalo.
this I'll check on it.
Good then. That's good if you've done the same thing. You can also compare my answers and your answers once after setting a seed of 1. They should now exactly match.
That's what I'm not getting, sir. Like, where is the answer is
Okay.
not.
Fair enough. Anyone, I'm just pasting my answer in the chat box. If at all your answer is not matching with me, just let me know. You can just share your screen and we can discuss that. Yeah, Ria, go ahead. You can share your screen. Seed 1, 10,000 sample X, mean of S, putting it into mu. See, you took quantile of X. You have to take quantile of mu.
Oh, yes, sir.
Okay, great. Others?
Got it, sir.
Got it? Great.
I
Great.
also done the same thing, but I didn't get the answer.
No worries, no worries. You can share your screen. We can have a discussion on that. Okay, X is set, this is set, mu is C. For I in 1 to 10,000. You have just written for I in 10,000. Yeah, you'll have to set the seed again if at all you have. Otherwise, I think you're good to go. You can just run it out. Not a problem. You're running the same line again and again. Correct. Yeah. Now you start to execute. Again, something looks incorrect. X mean 1:10,000. Our answers in decimals, right? Point. Why are you getting it in 2 point something like that? Arey, madam, you took 0.25, 0.025 is the range. In quantiles, 59th line, probs is 0.025, right? The upper end still is still the right, but I think still you will not get the answer. Just run line number 59. I think still there seems to be some issue. Yeah. Okay, yeah, this is still not working though. What is different here? X, you have that into place. Mean is there. Just run everything from line 51 once. Yeah, yeah. Just go ahead. Yeah. Now it's coming, right? You never executed X, I think, at the very first place. Fair, I think this is good to go. Everyone good to go, guys?
Yes, sir.
Okay, so what would be the last part? 4 marks. So the fourth point, comment on the differences between the confidence interval in part 2 and 3. Yep, anyone would like to make a comment? Yes, no.
Exact, no. One is
Both
exact,
are
one is
almost
bootstrap.
the same.
Correct. One is using the original method, what you guys have studied in your books. One is using bootstrapping method. Correct.
So it will be different. It has to be different, no?
Yeah, it has to be different. But then what is it that you see? That also you'll have to try and answer that out, right?
Both mean are same, then we can say that our parameter is approximately following our distribution.
Okay, fair. So if you see this range, what you have, and this range, what you got from the confidence interval. Firstly, you will always compare these two intervals, right? So kind of when you compare these two intervals, you see that this interval, what belongs to my original distribution using normality assumptions, I hope you would appreciate and see this is a wider confidence interval than this one. When I say wider means the width of this confidence interval is higher, which means
Yes,
this entire interval can fit within this interval. I hope you appreciate that.
yes,
The interval what you have got from the bootstrap approach is a narrower or is of the narrower width than the original one. Now that if you try and see, the answer lies within the standard deviation or the standard error of that quantity. So the standard error of bootstrap is about 0.067, while the standard error of your normal distribution is turning out to be 0.069. Correct? Hence, you see that gap in both of the width of the confidence interval.
That means bootstrap is much more reliable, you see, because small, narrow range.
Fair enough. Yeah, you can say it has comparatively a better precision of estimates as compared to the normality one. Yes. Yeah, in that sense, yes, correct. Everyone comfortable, good to go?
Yes, sir.
yes, sir.
So how are we to comment in this question, like comparing the second and the third
Correct.
question's confident interval?
Correct.
Bootstrap is much better. Like
Bootstrap
it
has a
is,
narrower width when compared to the one of normal distribution assumptions. The core reason lies between there's a difference between the standard error itself. Hence, you see that delta. That's it.
okay, sir.
Good to go, everyone. Yes, no.
Yes, sir.
Okay, thank you. Yeah, so technically, if you see here, I have just plotted a QQ plot for X. So broadly, you see you do have some outliers over here, right? Not falling on the straight line. Correct. So since the data is C, the data in itself is very small at the very first place. Now, even in that, if you say 2 to 3 data points here are, kind of moving or deviating a lot from the benchmark line, then maybe the confidence of, distributional assumptions may or may not hold true. Broadly, I think this holds true. The assumption holds true looking at the QQ plot. I think they are just 2 points. Broadly, the entire mass kind of falls into the place. But now let's say if you kind of doubt this chart itself, that okay, I'm not confident that my X only follows normal distribution, then technically you would still kind of doubt whether things will now start to follow in place for the entire test or not. Make sense, everyone? Is that good to go?
Yes, sir.
Great. All right. First question, can we close up with that question, everyone? Can we move on to another
Yes.
question? Great.
Yes.
I think let's start with this one. This is again already shared with you guys. Again, I'll give you guys 5 odd minutes. At sharp 10, 18, or 19, let's say we'll start to discuss. Chalo, get started, everyone. Chalo, guys, can we start to discuss this question as well? It's 10:18.
Doing, sir. A few minutes.
Okay, okay. I'll give you guys, let's say, up to 20, 10, 20. Okay, we'll start discussing at 2020. What about others? Anyone wants me to start? Or even we are solving it further?
Yeah, so doing.
Okay, okay. Fair, fair. I'll just mark the attendance in the meanwhile. Okay, we started at 8. Unit 3. Bhavani is there. Kaustubh is there. Riya is there. Anushka is there. Ali is there. Tom is there.
Got it, sir. But
Got
it's very big.
big in the sense? Program.
No program now. Confidence in the my
Confidence
confidence
interval
interval
तो
lies
पूछा ही नहीं है.
between 73.
But confidence interval is not at all asked in the question. Okay, no worries. Let's
It's
try
the
to
data,
solve it.
no? Using
But they are trying to model the person, investigate the person
goodness,
model is appropriate for it or not. So
Correct.
we need to draw the histogram.
Fair, fair. No, no worries, no worries. Let's try to see it together. The question is the following data represents the average total number of marks obtained for a particular exam observed over 7 exams that have been administered by a professional exam body. So these are nothing but the average marks given to you. So simple, it's question 1. And the data what I have, let's say capital X equals all of these data observations. Yes, someone's trying to tell something. Yeah, Bhavani, you have anything to add?
Sir, I
Mhm.
like in my output, I was supposed to get a single value, right, for the
You will
second.
not, no, you will not get a single value. You will have 10 set of value.
Yeah, I got 10 values for mean and 10 values for
Yeah,
variance.
that's how it has to be. That's how it has to be. Correct.
Okay, then.
Yeah.
I had a
So,
confusion.
sorry, there are.
No, I had a confusion in that.
Yeah,
No.
yeah, I'm just coming to that. I'll just quickly wrap up the coding part first. Then we will start discussing, any concerns or questions we have. Yeah. So the first sub part is just to enter the data and compute the sample mean and variances. So we know how do we calculate sample mean. It's simple. It's mean of X. Sample variances, we know it's var of X. So great. Good to go. Nothing to worry. Next, it says investigate whether the Poisson model is appropriate for these data sets by calculating sample mean and variance of 10 Poisson samples. Now, when they are saying 10 Poisson samples, is it a parametric bootstrap method or is it a non-parametric bootstrap method?
Parametric bootstrap
Good.
method.
It's a parametric bootstrap method. Very good. So since I have to generate 10 samples, my I will go from 1 to 10. Sample comes from Poisson, hence R poise. Let's say the length is same as length of X, and it would be lambda would be mean of X itself. Let's say I have my sample coming up over here. I have to calculate sample mean and variance for both. So let's say I'm setting MV to a blank vector. I will have to initiate MI as mean of S, and similarly I'll have to do var of S as V of I, right? So that's it. This much is the program. Again, let's set a seed so that every one of us gets the same answer. So I'm setting a seed of 1 again. Seed is executed, blank vectors created, loops are generated. And now when you see M and V side by side, did I do something wrong? I think I
You
never,
didn't run the X.
yeah, I never executed X, correct. Yeah, fair enough. So now, let me just round both of these guys to 2 decimals. I don't want to see so many decimal places. I'm just, let's say 1 decimal, I think is more than enough. I'm just rounding it down to 1 decimal. Yeah, fair. So now the question also says investigate whether Poisson model is appropriate or not. The first vector you see over here on my screen is nothing but with respect to mean. The second vector what you see on my screen here is with respect to the sample variance. How would you evaluate whether a Poisson model is appropriate here or not?
Goodness.
Mhm. What characteristic of a Poisson distribution is something very unique?
That is mean is equal to variance.
Yes, very good. One very key characteristics of a Poisson distribution is that its mean and variance are equal, which means that this number from the first sample mean should kind of be equal approximately towards the variance of the same sample. Guys, are
Yes.
you following this? Yes, but is it close enough? Not exactly.
Hmm.
Fair enough. Not confident or not comfortable saying it is exactly close, but then it is not very far apart also. So kind of in the middle. Fair enough. What about the second part? 75.9 and 16. So I'm saying my mean is 76 approximately, while my variance is 16. Definitely not in the line. Similarly for 80.4 and 89, if you see, not in the line. Same. So for each of the set, for each of the 10 pair of observations, what you have calculated, you see it's very less number of times the observations match. 81 and 83, yes, close enough. This is the only pair which you would be confident enough in saying that, okay, mean and variance is approximately the same. Rest for all the other 9 pairs, you would kind of not be confident in commenting that mean and variances are equal. Since mean and variances don't stand out to be approximately equal or nearby for that matter, you say that Poisson model is inappropriate for this data. See if that commenting makes sense. Yeah, and Bhavani, yeah, now you can let me know if you have any confusion or doubts.
No, sir. Yeah.
I think that got cleared by the explanation, right?
Yes, sir. Yes.
Okay, great, great. Others, were you able to follow the same program what I've written on the board?
Yes.
Yes, sir. I do the all the same, but I just done one extra thing.
What do you
And
have an extra thing mean?
means that quantile I represent um,
Ha,
confidence
so,
interval.
so fair enough. So technically they never asked you for confidence interval. So, matlab, even if you calculate, there's no inference coming out of it. So the
Yes,
question
sir.
is Poisson model appropriate? So So if you're trying to, let's say compare quantiles for, let's say, mean and variance, and then try to say that, okay, the confidence interval is very different, and trying to comment something like that, then that's still fine, not a problem.
If I done that much, then how much marks you give me for this question?
What you
Mm.
calculate? I think if everything is the same and just did you calculate mean variance at the very first place?
Ah, yes.
Yeah, then that's okay, right? It's just you kind of missed the end part, right? So how much marks it is? It's a 6 marker question. So 1 mark, 6 marker question. So let's say, 1.5 mark will be for commenting. So, technically we'll use about the same 1.5 to 2 marks out of the 6 mark.
Okay.
Good to go everyone, this question. Comfortable?
Yes.
Yes, no.
Yes, sir.
Chalo, let's take one last question and then we stop for the day. Um, let's take a simple question so that it's too simple. I think we can take this question. This one is easier one. Acha, but for that I never taught you guys our data. ठीक है. Okay, guys. So let's program wise, let's close here for the day. Since we have 10 minutes, I will quickly introduce you guys to something called as R workspaces. Then we close for the day, right? Let's have this one last concept. So nothing for you to do now. Just listen, sit back, listen to this concept. Very easy concept, and then we'll close for the day, right? Now, if you see my environment of R, right? There are so many variables that I've created, correct? And obviously, when we shut down the PC, everything gets wiped off, given that you never saved them. So often, what happens is that, I may want to save everything what I have in my R's memory. I want to save that. Right now, there are various reasons to do that. One reason is obviously because when I open my PC back on Monday after the weekend, I don't want to spend time running the same program again and get the output, because obviously it will be very time consuming. Because in reality, data sets are so huge that for you to, let's say, run a particular line or set of program, it may also take a day or two, right? When we make regression models in academics, we just press control enter and we have our output, correct? In reality, some models take days or at time even weeks of time to get fitted, right? So in that case, I don't want to close my programming tool and spend another 5 7 days to run the same thing again and again. Hence, what we do is we kind of save the entire environment on our local PC. So just like you save your data in an Excel file, in a CSV file, in a text file, in any other XYZ format, you also have a mechanism to save your entire environment on a local. When I say local, means on your desktop, in your document, in your drive, anything of those forms. So that the next time when I open R, or let's say if I'm going on a vacation and I want to, give my partial work to my colleague, then again my colleague will not take my R code and keep running everything again. I can just give my R code and I can give my environment. So let's say if I have a 2000 line of program and I was at 800 lines, my colleague can start from 801. My colleague doesn't have to spend time running those first 800 line of program again and waste time. Fair enough. So for these objectives, we always prefer saving our global environment, what you see on the screen. So how do you do that? You use the function called as save image, and you just give the path where you want your entire environment to be saved, right? So let's say So let's say I want to save it on my desktop. So I am just getting my path for my desktop, right? Again, in desktop, what is the name that you want to give to your workspace? Let's say I'm just seeing it as R workspace for now, right? And the extension of R workspace is always capital R and data. So whenever you see an extension of .r data, it means that it's an R workspace, right? So when I execute this, you will see it has successfully executed. And if you see my desktop, you have a file named as R workspace here. So now let's say if I just close my R, as I said, don't save. And if I again open my R, obviously since you never saved everything or anything of that format, right, everything will get wiped off. So whatever hard work we have done to solve something, execute something, everything gets wiped off, right? So I'll just press the broom button again. So if you see, the environment is empty. Now let's say if my colleague wants to load all the variable, everything what I have worked with respect to, all my colleague have to do is use the load function in R, and it has to give the path where my workspace lies. Correct? If you see my environment is empty, now I will press Control Enter and you will see automatically all the variables what I had initially before closing R, everything will come up back on its own. 3, 2, and 1. See, all the variables what we created, v, m, mean, oi, prob, everything comes back in my environment. So now my colleague or even me, if I have to directly start working after a short break or a weekend or whatever it is, I can directly start from this point. I don't have to run everything again to get things from scratch. Because in reality, things takes time to get processed. Days, 2 day, 3 day, 4 day. So you don't want to waste time processing things again. So you keep on saving your work in our workspace or in terms of our data so that you can directly start wherever you left behind. Is that making sense? Is that simple to understand, everyone?
Yes, sir.
Great. Others? Thanks, Bhavani. Thanks, Anushka. Others? Kaustubriya, Tom, Ali.
Yes, sir.
Okay, great. So now, as far as your examinations are concerned, examiner also gives you some data in form of R data. So if you see this exam paper, the examiner says the data are given in the file name csv waves.r data. So basically you will have to use the load function to get this data set into R and then start working with respect to whatever questions the examiner is asking you. Everyone good to go? Is that making sense? Simple. So whatever, I think Kaustubh and Riya might have shared some zip file yesterday. So keep that ready in your PC. It has a lot of these CS1R data files. So whenever we solve all of these questions, we will be required to import the data first using the load function and then try to solve whatever has been asked in the question. So just like you learned how to import CSV files, just like you learned, Jay, just a minute, huh? Yeah, sorry. So just like you guys learned how do you import a CSV file and Excel file, this is just another form of a, you can say a file where, you are supplied with data, or you can save data with something like that. Is the entire concept of R workspace clear, everyone?
Yes.
Okay, others confident enough, good to go.
Yes, sir.
Chalo, great. So we'll practice more on this when we actually start to solve the questions next class. I mean, not next class exactly, whenever things comes forward. So yeah, with that, unit 3 gets closed. I think one major concern as of now is bootstrap. No worries, go home, take some time to refresh. If at all you guys are still not, you can discuss it within yourselves. If you want some more clarity on that, just ping me anytime before, on Thursday or Friday. I'll prepare something to have some better understanding for you guys. Good to go, everyone.
Yes.
Chalo, great then. With that, let's close for Unit 3 for the day. Let's meet next week to start Unit 4. Chalo. Enjoy your partial weekend. See you guys next week. Bye bye.
Thank
Thank
you.
you, sir.
Thank you. Bye bye.